So good afternoon, everyone. Very delighted to be here for the first time presenting at FuturePrint. I'm Lekshmi. I'm from Archipelago. So about my background, I'm basically a physicist with a PhD in fluid dynamics. So today I'm going to talk about imaging techniques in inkjet printing and how we leverage those technologies to advance our powerdrop coating technology. So this is the agenda of my presentation. I'll begin by briefly introducing Archipelago, what we do, what we are capable of. Then I'll share some insights on my role at Archipelago, that is Knowledge Transfer Partnership Program. Then we will explore the journey of fluid dynamics, different stages of inkjet printing and different imaging techniques, finally data extraction and analysis. So Archipelago is an inkjet-based company based in Cambridge with a focus on droplet jetting technology. The main flagship of the company is the Powerdrop coating machine, which enables precise deposition of coating materials onto any substrate, including 3D containers, making them waterproof and oil-proof. So basically, we coat everything, starting from papers, paper-based trays, plates, including boxes, making them oil-proof and waterproof. So this enables the production of sustainable food packaging. So what we are trying to do is we are trying to reduce the usage of plastic by replacing plastic with coated paper-based food packaging. So now about my role at Archipelago. So I work as a KTP associate. It is a knowledge transfer partnership program funded by Innovate UK to connect academics to industry to drive innovation. And I, as a KTP associate, am the bridging person between these two worlds. So basically, a KTP associate will work at an industry on a designated project for a fixed period of time. So it's like a win-win situation for all parties. Now coming to the topic, the power of imaging. So why imaging is so crucial in technologies, especially in inkjet printing technology? So at its core, imaging is all about capturing this detailed visual information that will allow us to analyze, understand, and to understand what's happening even at microscopic levels. So through these advanced imaging technologies, we are basically unlocking new perspective across various dimensions. So we just don't see the droplet in motion now. We understand the fluid dynamics, how the droplets are formed, and how it interacts with various substrates. So this enormous data will give us the power to fine-tune every part of the printing process. So inkjet printing is like a dance of fluid. It takes various forms at different stages. The fluid stretches, it breaks up into smaller droplets, it travels and lands with precision. And the whole process is influenced by the key properties of the fluid such as surface tension and viscosity. So basically the surface tension controls the droplet formation and the liquid breakup, and the viscosity affects the fluid stretch and fluid flow. So imaging helps us to understand this dance of fluid, the whole process through real-time monitoring, without which we would be limited to indirect measurements like calculation, mathematical modeling, or even simulation, which may not capture the full complexity of the problem. So now by capturing the jetting stage, so we can understand and we can analyze the droplet formation, how the droplets are formed, the size of the droplet. We can track the velocity, the trajectory of the droplet. By recording landing and spreading, we can unreveal the liquid substrate interaction, the wetting behavior, spreading rate, and the coalescence of these tiny droplets to form a continuous and uniform coatings. So all crucial information to achieve a good printing or a continuous coating. So if we look at the time scale of the printing process, all the process operates on a specific time interval. If you look at the jetting, it's in the order of milliseconds. Again, spreading and landing, it starts from milliseconds to seconds, and for curing, it can take up to minutes. To capture each stage of this process, we need a proper selection of the imaging tool, and the proper lighting is highly crucial. So next we'll explore different techniques used in imaging in inkjet printing. So starting with high-speed camera and stroboscopic imaging. So from an R&D perspective, these two are the most important imaging techniques for characterizing the jetting and landing. So let's begin with high-speed camera. So as the name suggests, these high-speed camera, they are capable of capturing images at very high frame rates. So starting with 10,000 frame per second or 25,000 frame per second, or even more if you have an ultra high-speed camera. So how this high-speed camera work is, so these work as high shutter speed and low exposure time. That is, when you switch on the camera and hit the record button, the shutter will be moving like this at a very high speed. There's the amount of time the camera sensor exposed to light is very limited. That's in the order of microseconds. So effectively, the camera will freeze the fast-moving droplet in each frame. So this technique camera can be used to monitor the jetting process and the in-flight process. It can track the droplet size, velocity, trajectory in real time. And the next one is stroboscopic imaging. It is more of a lighting techniques. So here the main character here is the LED stroboscopic light. The specialty of this light source is it produces flashes of light which last only for a microsecond period. So effectively, and this time period is synchronized with the droplet motion. So effectively, the camera will freeze the fast-moving droplet. So next one is the regular DSLR camera. So these cameras are very handy when you want to take an image of your print for the quality purposes, to analyze the surface texture. If you want to record the spreading, or if you want to film the whole coating process, you can use this camera. Again, if you go to the manual mode of this camera, you can capture events in the order of a fraction of a second using low exposure time and high shutter speed settings. And next one is microscope, USB digital microscope. So since it is a microscope, it gives a zoomed and enlarged view of your dried ink pattern. So again, it can be used to analyze the interaction of liquid, your ink and the substrate. And again, it can be used to analyze the quality of your print, the finish and texture. And the next one is IR imaging. So IR imaging is quite helpful to analyze or understand your curing process, because it maps the thermal characteristic of the curing stage. So it helps you to identify any sort of inconsistencies or hot spots in your layers of ink during curing. So next is the role of imaging in high quality, role of lighting in high quality imaging. So imaging is the lighting is the fundamental key to capture high quality imaging, and a proper lighting can dramatically improve the quality and the details of the images you capture. So there are different types of light sources like spotlight, LED bright light. So these intense LED bright lights are used as in high-speed imaging, because in high-speed imaging the exposure time is in the order of microseconds. So during that brief period, you have to make sure that your camera sensor is properly illuminated. So that's why we use LED bright light for the high-speed imaging. Next is the position of the light source. How the position of the light source will alter the images we take. So the first one is the image of the droplet sitting on a paper substrate, and here the position of the lighting is just above the droplet. So this sort of lighting enhances the surface features of the droplet. It uniformly illuminates the whole surface. And if you look at the second one, which is shadowgraphy, here the lighting is placed just behind the droplet. So this sort of lighting produces a high contrast image, and these are very helpful for analyzing. These are used in high-speed imaging. These are very helpful for analysis droplet size, to track the velocity, because it produces high contrast images. And yeah, here basically the droplet casts a shadow on the camera sensor. That's why we are getting this black and white image. Now bringing it all together, at Archipelago we use various cameras to optimize our Powerdrop technology. So we use regular phone cameras, GoPro action camera, DSL camera, and the high-end Chronos high-speed camera. So this is the animation showing the working of a Powerdrop machine. So the heart of the Powerdrop is a Powerdrop drum, which is a hollow cylinder with large number of tiny nozzles in it, and we fill these nozzles with coating material using the Powerdrop filler, and the drum will be rotating at a particular speed. So there is a blower inside the drum which will jet out all the coating material to a substrate using a compressed air. So effectively you will be coating the substrate placed beneath the drum. So here we use various cameras, like we use DSLR camera and GoPro camera to look at the filling, and we use high-end high-speed camera to look at the jetting, in-flight and landing and spreading stages. So we perform experiments at various conditions like drum speed, blow pressure, and we try to refine the jetting as well as the landing of the coating liquid so that we can achieve a uniform and continuous coating. So coming to analysis and data extraction. So once we get all these images and information, next stage is data extraction and analysis. So we use various tools such as open software, ImageJ for image processing, and for more complicated and customized analysis we turn to MATLAB. Again we use advanced computational software Maple for computational modeling like energy balance analysis and all those things. So to conclude, imaging is one of the key important parameter for technique to characterize the printing process, and seamless integration of this technology with your printing process not only improves the quality, it also sets a new standard for effectiveness in industry. So looking ahead, we encourage all the industry partners and players to embrace this technology. Okay, thank you. Thank you for joining me.